Welcome to the review session on testing hypothesis, how is testing hypothesis is done, and how do we interpret the results. This lecture is prepared part of Pharmacoepidemiology PHA 514. First off, let me remind you of the steps, or maybe let me introduce the concept of testing hypothesis. Basically, what happened is this. A researcher has a research question that they would like to investigate. A research question usually ties up an exposure to an outcome. So the exposure could be, for example, receiving a certain treatment, and the outcome would be, for example, the occurrence of a certain outcome, maybe like it could be myocardial infarction, a disease, an event. And the research could be of a sort, does taking the medication reduces the risk of myocardial infarction or not? And what's going to happen is that the researchers are going to design their study where they're going to have a group of people taking the medication and a group not taking medication, and then they will observe the myocardial infarction in both groups, compare them, generate a statistical test, get the p-value, etc. So how does it work really? Well, what happened is that because you're working with samples and you're not working with populations, and therefore every time you're working with samples, the information that you generate from samples, this information is considered estimates. These are estimate value. They are not real values. The real values come from populations. So these estimate, by nature of things, they're not real value. There's always a probability factor that comes into the estimation process. And therefore, you would like to know, whenever you're doing something like this, um, does the observed result is a substantiated result, or is it only due to a problem or due to sampling issues? So for example, if you compare the group that was taking the drug, so if you compare your drug taking and you observe that myocardial infarction, let's say, occurred at this level, and for those not taking the drug, you observe the myocardial infarction occurred at this level. So obviously these two results are different. The question remains, is this really coming from a population? So this is the population level. Okay, so are we sure that this difference is real and really representative of what is happening in the population? Or could it be that in the population, in fact, these two groups are one and the same? They're not different. You excuse my drawing, so one and the same, there's no difference. So the question is what you're seeing in the sample, that difference that you observed in the sample, is it a real difference? A statistically real difference, or is it just a coincidence, an artifact of sampling, or what we call like a chance thing? So we ask the question, is whatever we observed here really reflective of what is happening in the population, or is it only a chance thing? Okay, and that's the whole idea of testing hypothesis. So how do we answer that question? The way we do that is that you start off with a simple assumption. You start with the assumption that, in fact, at the population level, you say, okay, I'm willing to assume that at the population level, there's no difference between the two groups. I'm going to say that these two groups are one and exactly the same. And then, knowing that you observe the difference in the sample, say, okay, knowing that I observed this much of a difference in the sample, then what is the probability of that occurring? If in fact there was no difference in the sample, what is the probability of me observing that much of a difference? And based on this probability, if the probability you get answering this question is a small probability, meaning that you should not observe a difference, if in reality in the population, at the population level, there was no difference, then how come you observe the difference? The answer to that, well, that means that at the population level, there was a difference. This assumption that I made right here, that there is no difference in the population, is wrong. Why? Because I should not have observed the difference. And since I observed the difference, then that my assumption is wrong. Think about think about it this way. If I were to tell you that there is a jar full of pebbles, and I tell you all the pebbles in this jar are black pebbles, all of them are black, okay? Then if you were to take a sample out of this jar, okay? If all if you if part of the sample you observe a red pebble, then what would you conclude? You will conclude that the information I gave you, that all the pebbles in this jar are black, is wrong. Okay? Why did you make that conclusion? Because you're not supposed to see this. You were not supposed to see a red pebble. If all of them, so you hear me say if, okay? So if all the pebbles were black, you were not supposed to see a red pebble. But since you did observe a red pebble, then this conclusion is wrong. Okay? And similarly, well, no, I don't know if should say similarly. If again you're set with the same principle, if I were to tell you in a jar all the pebbles are black, you take a sample and all the pebbles are black. Well, here there's nothing that occurred in this sample that would make you doubt the assumption that I gave you, and therefore you would accept my assumption. Testing hypothesis kind of like work in the same way. So going back to our example, if you start off with the assumption that at the level of the population, so let me restate that. If you start off with the assumption that at the population level, so this is your population level, okay? So if at the level of the population, you are making the assumption that taking the pill or taking the placebo does not make any difference, if this is your primary assumption, and if you and then you take your two samples and you compare them, and here two things can happen. Either your treated and the untreated are very similar, and that what would you expect to see if this is true, then you'd say, okay, well, that's what I was expecting anyway, and therefore I will conclude that there is no difference. However, in the event that you take a sample and then you look at the treated and you see them very different from the untreated, here comes the issue. Here comes the question. Well, I'm not supposed to see that. I'm not supposed to see them that different. If the assumption that we started with, that they were different, I'm not supposed to see that much of a difference. And since this occurred, therefore I have no choice but to go to my initial assumption and reject it and say, no, they're not different. They're not the same, they're different. Okay? And basically, this is how testing hypotheses work. Testing hypotheses works in the steps where you start off with your research question. Your research question would like to know if there is a difference between the treated and the non-treated. And so what you do is you start off with the assumption that whether you treat or you do not treat, that will make no effect whatsoever. So that's your startup point. Then you run your studies, you collect your data, and here you do the observation. You look at the results, and based on that results, based on what you're going to observe here, you're going either to say, well, if this is true, then I'm not supposed to see what I saw, and then this is not true. Or you may have the other way around. You were going to say, well, if what I observed is just confirming what I assumed, and therefore I'm not going to reject what I assumed. So everything I said so far is correct, except that the answer to the question, what I observed is what I expected or not, or was I supposed to see what I'm supposed to see? That is not a definite answer. That is more like a probability. Okay? So what's going to happen is you're going to say, okay, at the population level, I'm going to assume that there is no difference, no impact, whether they're treated or not. So that's the assumption that you're going to make. And then you're going to collect data, and then you're going to observe. And once you observe, you're going to ask a question. what is the probability of me observing the event that I observed if my first assumption was correct? If that probability is a very large probability, يعني it kind of like this is what you were expecting to see if really there was no difference, then you say, okay, well, خلاص, I'm satisfied. However, if the what you observed should not have observed, yani the probability of what you observed is showing a rare occurrence, something that should not have occurred, like the red pebble, and because it did occur, like the red pebble, you're going to say, well, obviously my starting point is wrong, and I'm going to reject that starting point. Okay? So having said that, this translates into several things when it comes to testing hypothesis. The first thing is the assumption that my starting assumption. What is the starting assumption? That's the first thing. The other thing, once I collect data, I collect a probability, and that probability is going to answer the question whether this assumption is acceptable or not acceptable. So what is this probability? Okay. And how do I determine if this probability is going to lead me to accept or to reject my assumption? Okay, so I talked about the probability being big or being small, but in fact, like, where do I draw the line between a big probability and a small probability? If you remember when we had covered probability in previous courses, a probability is a value that goes from 0 to 1. And therefore, when you're going to decide if a probability is big or small, it's going to be based on a cut point between 0 and 1. And that cut point has to be placed somewhere between 0 and 1. Now, hopefully by now, you know that the cut point is placed at the 0.05, and that cut point is called alpha. And therefore, if your probability fall into the what I just highlighted, yani into the big area, this is called the big probability, then the occurrence is not rare, and the occurrence coincide with what you were predicting. What you were predicting based on what? Based on the assumption, okay? And therefore you have no reason to doubt the assumption, you have no reason to refute the assumption. However, in the event of falling into this small area right here, so that's where your probability is actually small, yani the occurrence is rare. طب rare under what assumption? Under this assumption. If this is true, what you observed is tiny, is rare, it should not have occurred, and therefore you're obliged to reject the assumption and choose another conclusion. So this assumption is what we call the null hypothesis. And once you reject it, you're going to move into something else, which is called the alternative hypothesis. The null hypothesis and the alternative hypothesis derive from the research question, where the null hypothesis, as I just mentioned, is the assumption of nothing is happening, no change, no difference. Whereas the alternative hypothesis is where you're going to assume that actually there is something going on. Okay? So let's go back to our lecture and see if we can cover that in the lecture notes. So these are the steps of testing hypothesis. You start off using your research question to define the null hypothesis and the alternate hypothesis. Then the next step, you're going to assume the null is true. You're going to assume that the exposure and the outcome are not related. You're going to assume that the two groups in the population are not different. You're going to assume that taking the drug doesn't decrease the risk of myocardial infarction. Taking the drug does not lower cholesterol. Okay? So you make this assumption, and then you get yourself ready to calculate a probability. But before you do that, you draw your line of where you're going to start considering the probability to be large or small. هذا line رسمت لكم اياه من شوي يلي it's set at 5% conventionally. So alpha is set at 5%, knowing that in some research it's actually set at a different value. So you run your study, you collect your data. Using your data, you calculate your test. So here your test could be like a chi-square, it could be a t-test, it could be an ANOVA, any kind of test depending upon the situation. What is important is that that test is going to give you your p-value, okay? So a p-value is the probability of what you observed under the assumption that the null is true. Remember, the p-value is calculated under this assumption. If in reality there's no difference, then what is the probability of observing the difference that you observed? Okay, that is your p-value. And as we said, your p-value is either big or large, and your observations are either very rare or your observations are common. If they're common under the assumption that you made, under the null hypothesis, then you have no argument against the null hypothesis. If the observation is very rare, under the assumption that you made, that only can lead you to reject the assumption that you made. And therefore, to know whether this p-value is big or large, you're going to compare it to alpha. If your p-value is bigger than or equal to alpha, you fail to reject the null hypothesis, and therefore here you declare the differences observed in the sample due to chance only. However, if your p-value is small or smaller than alpha, therefore you're going to reject your null hypothesis and you're going to declare that the results are statistically significant. Okay? So when is the probability considered big or when is it considered small? We kind of address that. We're going to address it again, but this time in the slides. How do we define the null hypothesis and how can I get the probability? Hopefully I already kind of like addressed all of this at the beginning, but here we're going to come back to them in the slides. So when is the probability small and when it is considered big? Conventionally, the cut point between a small and a large probability is the 5%, which we call alpha. So when your probability or when your p-value is less than 0.01, then we have evidence that the assumption made is not acceptable. Okay. However, when the p-value is larger than or equal to alpha, then the event is not considered rare and we cannot reject the assumption or the null hypothesis. So what is a p-value? A p-value by definition is a probability of observing the results that you observed under the assumption that the null hypothesis is true. This is the key thing. So it's the probability of observing what you observed. So مثلا maybe you're comparing a treatment to placebo in terms of reducing the blood pressure, and you observed a drop in blood pressure of 5 units. The question is, what is the probability of observing this much drop in blood pressure if in reality the null is true? شو معناتها if in reality the null is true؟ يعني if in reality the drug is not doing anything to blood pressure. So this is the definition of p-value. Now, how do we define the null hypothesis? Null hypothesis is like presumption of innocence. The accused is innocent till proven guilty. It's the assumption of no difference between the groups. It's the assumption of no effect. It's the assumption of no difference. This is the assumption of nothing is happening. There is no impact. There is no change. دايما the null hypothesis is like that. Okay, so مثل ما قلنا in a court of law, someone is being accused of a crime. There's a presumption of innocence, and then you have to bring evidence against that presumption of innocence. Okay, if that person is really innocent then of stealing مثلا the money, so how come we found a large sum of money in their account? Okay, if really they were innocent, then we should not have seen this. And since we've seen this, then they're not innocent. Okay, so this same thing in research. Here's an example. What is the null hypothesis for each of the following examples? Comparing long-term cost of surgical procedure to medical treatment using drugs. The null hypothesis would be there's no difference in cost between surgical procedures and drug. Okay? Null hypothesis دايما بتقول ما في فرق. There's no difference. There is no impact. Okay? So what happened if the data observed showed that those receiving surgical treatment they end up paying more or over the 12 months. So لكن those that were receiving the treatment عم يدفعوا أكتر, and the p-value came out to be 0.002 for us a p-value, this is a small p-value, less than 5%, so we're going to reject. Then we reject the null hypothesis and conclude that surgical treatment is more costly. Okay, that's scenario number one. Scenario number two, if the p-value actually turn out to be 0.0871, هالمرة the p-value is actually larger than 5%, then we cannot reject the null hypothesis, and thus we cannot conclude that one method is cost more than the other. Okay, مع انه on the sample you are observing a difference in cost, but that difference is only at the sample level, it's not at the population level, and therefore we say that this difference is due to chance only. Another example, what is the null hypothesis for each of the following example? Comparing the risk-benefit ratio of different doses of Lipitor in treating patients. شو حيكون النال hypothesis? There is no difference in risk-benefit ratio among the groups taking different doses of Lipitor. Okay, null hypothesis بتقول ما في difference. So whether you give the high, the low, the medium dose, no difference. If the data observed showed that receiving higher dose have more benefit than risk, okay, so this is the observed. And the p-value, this is the key thing, and the p-value is 0.01, يعني this occurrence should occur only 1% of the time. If, and that's the key point, if in reality there is no difference. So what you observed is very rare. You should not have observed it. But since you observed it, then you reject the null hypothesis and conclude that the risk-benefit ratio for higher doses of Lipitor is better than the lower doses. Okay? However, if the p-value was 0.245, and hence what you observed is actually quite common, therefore you may not reject the null hypothesis and you may not conclude that the difference is statistically significant, and in that situation you will conclude that the observed difference is due to chance only. Now, in testing hypothesis, we cannot prove something to be true, but we can refute something. So this is the refutation approach. يعني ليه in testing hypothesis بنبلش بالnull hypothesis? Why our starting point is null hypothesis? غير إنه presumption of innocence. Another reason why we do it, it is because it's always easier to show something is wrong than to show something is right. So أنا كresearcher, if I want to show, if I'm interested in showing that the drug has an impact on the health status, okay? Proving that is much harder than showing the opposite to be false. The opposite being, the drug doesn't impact the health status. If I'm able to refute that, then I can jump into the conclusion of saying that the drug helps, okay? So the idea is called the refutation approach. The refutation approach says refuting something is easier than proving something, okay? So if you have the option of to prove something directly or to go the indirect way, so you pick the opposite of what you want to prove, you refute the opposite, it takes you back to what you wanted to prove, okay? So you only need one evidence against a hypothesis to show it to be wrong, but not finding that evidence doesn't automatically mean the hypothesis is true. It can be that you haven't found it yet. So هذه الجملة just in support of the refutation being an easier approach than the proof approach. So having said that, we need to discuss p-value, error, power, effect size, and sample size. So p-value, we already kind of like approached the p-value. It's a probability, and this probability is used to make a statistical conclusion, whether you reject or you fail to reject the null hypothesis. And the definition of the p-value is the probability of getting the results you observed if the null hypothesis is true. Okay, so under the condition or under the assumption that there is no difference, show the probability that you observe that much of a difference, that is your p-value. So here's an application of definition. researcher testing the length of stay of patients treated with meropenem versus those treating with levofloxacin. The null hypothesis is that the length of stay is the same. The null hypothesis would say there is no difference. The results show a difference of 1.4 days. Okay, so نحن عم نقول ما في فرق. We're assuming ما في فرق. At what level we're assuming ما في فرق? At the level of the population. بس نحن our observation is that the level of the sample. بما أنه our work is at the level of the sample, you're not observing reality, you're observing estimates. So the question is, even though in reality there is no difference, can you observe a difference of 1.4 at the level of the estimate? The answer to that question is your p-value, and the p-value comes out to be 0.012. So how do we interpret this 0.012? This is the probability that a difference of 1.4 days or longer would be observed in our sample if, in fact, there was no difference in the population. So the probability is 12 times per 1,000 studies. So that's what the p-value means. P-value means that this much of a difference occurs only 12 per 1,000 times if in fact there was no difference at the population level. Yani, this is a rare occurrence. This is something that should not have occurred. However, since it did occur, what are you going to do? Yani, how are you going to evaluate this p-value? Are you going to consider this p-value to be large or big? Well, remember, we evaluate the p-value compared to alpha, yani the 5%. This is lower than 5%, so we're going to consider this probability to be small, yani the occurrence is rare, it should not have occurred. Since it did occur, we're going to reject our null hypothesis that says there is no difference, and therefore we're going to declare that there is a difference, and we're going to declare that the observed difference is statistically significant. Okay? Type. Then that leads us into defining type 1, type 2 error, also defining power and 1 minus alpha. So every time you're testing a hypothesis, a reality which is at this level here could be يا أما that the null hypothesis is true, يا أما the null hypothesis is false. This is the reality. This is what we do not know. لو كنا بنعرف reality ما بنعذب حالنا نعمل research with statistical testing. But hypothetically, you can imagine that in reality, يا أما the null hypothesis is true, يعني يا أما the groups you're comparing are not different, يا أما they are false, يعني the group you're comparing are different. However, our work is at the level of the results from the statistics and from the samples and the studies we run. So your statistics are either going to lead you to fail to reject the null hypothesis, or they're going to lead you to reject the null hypothesis. Okay? So our decisions are either reject or fail to reject, whereas the hypothesis is either true or false. And out of that, you have 4 possible scenarios that occur. If the null hypothesis is true, يعني ما في فرق, and you're failing to reject the null hypothesis, then you're making a correct decision. However, if the null hypothesis is true, but your results for some reason are leading you to reject it, then you're making a type 1 error. It's a wrong decision. It's a decision where you are declaring that there is a difference. However, in reality, there is no difference. And this is what we call the type 1 error. And it should occur 5% of the time. The 1 minus alpha should occur 95% of the time. يعني إذا أنا I run 1,000 studies, let me make it easier. If I run 100 study, إذا أنا I'm comparing placebo A to placebo B, اثنيناتهم placebos ما عندهم فرق بيناتهم at all. And if I have the funding to fund 100 study, independent study, and I say to them, please compare these 2 placebos, what should happen is that 95 out of the 100 study should come back and say there is no difference. However, 5 are going to come back and they're going to tell me there is a difference. They would be wrong, obviously. And the type of error they committed is called the type 1 error. Now let's move to the other arm. If in reality a difference does exist, yani if in reality a drug does have an impact, However, your study failed to show that impact. What you have committed is called a type 2 error, also referred to as beta. And that should not occur more than 20% of the time. So this is where a drug actually works, but you're not able to show that it works. And the last square is when a drug actually works, the null hypothesis is false. في فرق between the two groups. في impact, في treatment effect, في efficacy. However, you are able, you are able to show that difference. That is the power of the study. And it should be at least 80% or more. And you can understand why researchers are very excited about power, because this is the piece that will allow them to say that my drug actually has an impact. My drug actually changes the markers of a certain disease. Okay? So again, to redefine Shumanita 20 or 80%, imagine I have a drug that actually has efficacy, a drug that actually does reduces blood pressure. And if I were to recruit 100 researchers and ask them to compare my drug to placebo, what's going to happen is out of the 100 researchers, 20 are going to come back. طبعا كل واحد منهم is running an independent study. 20 of the 100 studies are going to come back and they're going to tell me there's no difference. They would be wrong and they would be committing what we call a type 2 error. And 80 out of the 100 are going to come back and they're going to tell me, yeah, there is a difference, and they would be right, and that they would have achieved power. Okay? So هون هن the four scenarios that can occur. A simpler way that we can talk about them, or is an easier way for you to remember these, think about disease status. So a patient may be healthy or he may be diseased, and you're testing them. You're testing them, and the test results can be either negative or positive. إذا البيشنت عن جد healthy والتest is a negative, then that's a true negative. Okay? And this is the 1 minus alpha we discussed. أما إذا البيشنت is healthy but for some reason the test came back positive, يعني أنت you are saying there is a disease, or the patient has the disease وهو بالحقيقة does not have the disease, so you're declaring a false positive result. This is your type 1 error. This is alpha, and this is what should not occur more than 5% of the time. However, if in the other hand, as patients do have the disease, while tested, the test come back negative, that would be a false negative, and that's what we've been calling in the research the type 2 error. Failing to detect something that actually exists. This is your type 2 error. And this is the big nemesis of researchers, to fail to detect something that is out there. However, if you are able, if your test comes back positive, for someone who actually has the disease, that this is a true positive result, and this is your power, and that should occur at least 80% of the time. Okay? So we have said that power is a concept that researchers are very interested in. So think about a drug company that is making drug that lowers the blood pressure. To test the drug, the company is going to run a research study. And in this study, the null hypothesis is going to be that the blood pressure does not change. This is the null hypothesis. Obviously, they believe the null to be false, and obviously they want to reject the null hypothesis. So obviously they want to put all their effort in rejecting the null hypothesis. Mention هيك, when they run the study, they would probably want a power of حتى 80% would not be enough. They might need a power of 90 or 95%. So the researchers of the company believe the drug work. Thus, they believe that the alternative hypothesis is true. Thus, they really want to reject the null hypothesis, which they believe it to be false. They don't want to miss the chance to provide this evidence. So what is described is power. They want to reject a false hypothesis. Rejecting a false hypothesis is power. Okay, so here's an example. If I'm comparing meropenem to levofloxacin, setting the study to have a power of 80% mean that if in fact there is a difference in the length of stay between the two patient group, we would have to define the minimum difference, but we'll get back to that. Then there is 80% chance of detecting this difference. That's what 80% power means. It means that if عن جد في فرق عندك, you have 80% chance of detecting that difference. So again, with the example, 1,000 studies studying that same question, however independently from one another, what's going to happen is that 800 of these 1,000, and 80% of the 1,000, will finish by rejecting the null hypothesis and therefore declaring that there is a difference, whereas 200 will fail to reject the null hypothesis and thus reaching a type 2 error, an error of failing to find a difference. شو معناتها a type 1 error? If in reality there is no effect of coated stent as compared to non-coated stent with regard to growth of vegetation, nonetheless, شو لنقول this is the reality, ما في فرق whether you use a coated stent ولا non-coated stent. Nonetheless, a study found a higher rate among the non-coated versus the coated with a p-value of 0.042, and thus they ended up rejecting the null hypothesis. شو صار؟ هذا study is going to declare that في فرق بين coated non-coated. They're declaring that something exists when in fact it does not exist. That is considered a type 1 error. A type 1 error where you declare that there is a difference, you declare there is an effect, whereas in fact there is no effect. And it does occur 5% of the time. Okay? Type 2 error, if in reality mixed insulin regimen versus basal insulin regimen leads to better fasting blood sugar control, if in reality في فرق. So هون كمان again we are in the scenario where the null hypothesis is false. There is an impact, there is a change, there is an effect. However, your study yielded a p-value of 0.0712. So you're going to fail to reject the null hypothesis, and you're going to declare that there is no difference. So you're failing to detect an effect that actually exists. That would be a type 2 error. Okay, so نفرق بين التايب 2 error والتايب 1 error. وحدة بتشبه الفولس positive, الثاني بتشبه الفولس negative. Which one resembles the false positive? The test is positive, but the patient is healthy. So the results are saying there is a difference, whereas in fact there is no difference. That is your type 1 error. The false negative, the test is negative, whereas in fact the patient does have the disease. So you're failing to detect the disease. Okay, this is your type 2 error. Failing to find a difference, failing to find an effect, whereas in fact the effect does exist. Okay, so that leads us to the third part of testing hypothesis, where we have to talk about how does power relates to sample size and effect size. Okay, هو in fact they also relate to alpha, but most of the time alpha is set at 5%. So ما هالقد بنهتم بالفا لانه we set alpha at 5%. بنهتم اكثر بباور. يعني انا كفارماسيوتيكال كومباني مثل ما كنت عم لكم من شوي، انا ما بدي الباور 80%، بدي باور 90%. Can I do something to increase my power of my study? Yes, you can do something. Okay, and obviously what you can do is increasing your sample size. So let's talk about these things. A researcher used the relationship between the four parameters. مين هن الفور parameters؟ قلنا power, effect size, sample size والفا. بس نحن حنفوكس أكتر على power, effect size sample size. We're not gonna focus too much on alpha because alpha is usually set at 5% and it doesn't change. So what researchers do is that by figuring out the values of three of these four, they can determine what would be the value of the last one. Okay, هلا طبعا most of the time we're after sample size. يعني researchers بيجي بيقول اوكي اذا انا my type 1 error or my alpha is 5%، خلص هذه معروفه، انا بدي power of 90%، so هعطاك الباور. بضل في عندك شغلتين، بضل في عندك شو sample size وشو effect size. So you may ask them, okay, so your drug is supposed to reduce blood pressure by how much? Be like at least 10 units. So now that you answered the question for alpha, for power, and for effect size, you can use a calculator to get what is the sample size needed. So you heard me talk about effect size. شو معناتها effect size? Effect size is simply the standardized difference expected to be seen between the two groups. For example, two groups with equal hypertension level, one treated and the other one not treated. By how much I would expect the blood pressure to drop. This is your effect size. Okay? So effect size is like إذا عم نحكي على efficacy of a drug بتقلي هذا drug is effective in treating, like how is it effective? بتقلي it reduces the risk of myocardial infarction. So by how much does it reduce the effect size, the risk of myocardial infarction? You may tell me it reduces it by 20%. See that 20%? This is your effect size. This is the impact of the drug. If you're studying drug, you may be studying something else. Hatta when you're talking about side effects, you may tell me, well, comparing these two drugs, this drug has more effect size. So when you say more effect size, I'm saying effect size. So hatta when studying side effects, okay, adverse drug reaction, side effects. So you tell me this drug A has more side effects than drug B. اوكي سو انا بجي بقول لك اوكي سو قديش اكثر بتقلي for example 20% 50% 10% more than drug B. So by answering that, you are telling me what is the effect size. So effect size is like a quantification of the difference in a standardized manner. Okay, so effect size is how much of a difference exists between the two groups. Okay, so power is affected by effect size and it's affected by sample size. كل ما sample size is bigger, the bigger is your power. وكل ما your effect size is bigger, your power is bigger. Think about it. هلا إذا أنا لحالي I ask you, I'm comparing drug A to placebo. Okay? In one study, I'm recruiting 100 patients. In another study, I'm recruiting 500 patients. Which of these two would you would think has a better chance of detecting the difference? You're probably going to say the 500 patients, okay? بتكبر sample size بيكبر الباور. تذكر what is power. It's the chance of your probability of declaring that there is a difference when in fact there is a difference. يعني your probability of actually detecting the difference. كل ما كبر sample size, كل ما you are able to detect your difference. Think about it as a microscope. Your sample size is your microscope. كل ما your microscope is powerful, كل ما you are able to see the difference that you're looking at. Okay. هلا if you're provided with one microscope, not two, and you're looking at two things, one that is big and one that is small, you'll obviously see the bigger one easier. Okay, so that's effect size. كل ما effect size is bigger, كل ما you have more power. Think about it again, going back to the example. You're comparing drug A to placebo, and you're comparing drug B to placebo. Drug A reduces the risk of myocardial infarction by 3%, whereas drug B reduces the risk of myocardial infarction by 15%. Obviously, drug B is stronger, عنده a larger effect size. If both of them are studied with the same sample size, which of the two will have more power? Which of the two has a better chance of detecting the difference? أكيد the one with larger effect size. Okay? So in that, I would like to show you this figure. This figure is coming from an article published. I may put the article for you to see it. And this figure helps you link these concepts that we just discussed. So in this figure, what you have is on this side right here, you have power going from 0.995, 99%, 98%, 90%, 80%, and all the way down. Remember, نحن minimum power is 80%, okay? So probably you will be interested in 80, maybe 90, maybe 95%, okay? On that side, you have effect size, and your effect size, they don't really tell us what this effect size is, but I mean, bear with me, we're going to go with the example anyway. So going from a non-existent effect size to a small effect size of 0.1, 0.2, and the effect size increases, okay? So what this figure does is, by when you pick the power that you're interested in and you pick the effect size you're interested in, by joining these 2 points, you're going to cross the sample size needed. See these 2 lines here? This is your sample size. One for alpha 5% and one for alpha 1%. Okay, so by linking, you're going to figure out your sample size. Let's look at an example. Here's an example. Okay, in this example, the researcher is interested in, for a power of 80%, so بيجي على side here, that's his 80% right there. He thinks that the difference he's looking at, the effect size, is 0.78. So this is the 0.7, this is the 0.8, 0.78 is right there. And what he does, he draws a line between the 80% and the 0.78. And that line is going to cross the ladder of sample size in 2 places. One for alpha of 5% and one for alpha at 1%. So if he desired to run the study at an alpha of 5%, he would need about, let me see if I can make it bigger, and maybe if I make it bigger, it's easier to see. Okay. He would need about 50. Okay. If he wanted to run the same study at alpha at 1%, which makes it harder to run, then the line is crossing here, and that makes the sample size between 70 and 80. Okay, let's look at another example. So بعده using the same effect size 0.78, بس هالمرة he wants a power of 95%. So now he's going to link the 95% with the 0.78, and look where does the line crosses the ladder. At 5%, it's crossing the ladder at about 85. So when the desired power كانت 80%, he needed about 50 individual. ولما صار the desired power 95%, the sample size increased to 80% for the same effect size. Okay? Let's see. So let me try to recap that as much as I can. All right. So is عندنا alpha equal 5%. Okay, and and if you have an effect size that is constant, that you're not changing, it's the same constant effect size, and then you want your power to change from, let's say, 80% power, excuse me, this is 80% to 85%. Maybe you're not satisfied, you want 90% power, maybe you want 95% power. So what's going to allow you to change your power from 80 to 85 to 90 to 95 is your sample size, how many you're going to recruit, okay? And what's going to happen is that your sample size is going to get larger and larger and larger. So maybe you start with 10 and then you move into مثلا 18, maybe all of a sudden you need 35 and you may end up with 190. Okay, so that's scenario number 1. But that more power for the same effect size, you need a larger sample size. Whereas if you are comparing multiple studies, so again, we're going to go with alpha 5%. So alpha is 5%. We're not changing alpha. And power, let's say, is 80%. So it's the same power. ما بتتغير. Okay. However, you have drug A versus placebo. Excuse me. على خطي اللي ما ظابط. And you're comparing drug B versus placebo. مش حارجع اكتب placebo. خلاص, you understand what I'm doing. And drug C versus placebo. And let's say that the effect size of this one is 2% change. This one is, let's say, 7% change. and that one is 24% change. Okay, so to able to reach 80 power بكل وحدة من هول, you may need maybe 400 patients in this study. In B, since B has a stronger effect, you will need less. Maybe you will need 310. And since C has even a stronger effect, you might just need 110, for example. All three studies will have a power of 80%. Different sample size because of different effect sizes. All right, so that concludes the review of testing hypothesis. I hope that you found this lecture helpful.